In our last video, we revealed the backbone of the internet, the 13 core types of servers that power everything from websites to email to multiplayer games. But guess what? That was just scratching the surface. The internet is much more than web, mail, and file servers. Behind the scenes, there's an entire second layer of digital workhorses, specialized machines running silently to manage identities, balance traffic, scan for threats, host virtual environments, and much more. If you thought servers were just dusty racks in data centers, think again. In this episode, we're diving into 13 more types of servers you should know. These are the machines that power advanced networks, manage virtual machines, keep things secure, and make sure your apps and services don't crash under pressure. If you want to level up your understanding of how modern tech works, this is the video for you. Let's get started. 1. Load balancer server. Let's start with one of the most important servers in large-scale networks, the load balancer. Imagine a website getting millions of visitors per hour. If all that traffic hits a single web server, it's going to slow down, or worse, crash completely. A load balancer steps in and distributes incoming traffic evenly across multiple servers. It's like a digital traffic cop, making sure no single server gets overwhelmed. The result? Faster performance, more reliability, and no downtime. Load balancers can work at the network level or the application level, and they're essential for cloud services, major websites, and apps that scale globally. 2. Domain controller server. Now let's talk about identity and access. In large organizations, keeping track of who can access what is critical. That's where a domain controller comes in. A domain controller is a server that authenticates and authorizes users and computers in a Windows domain. When you log into your work laptop, the domain controller checks your credentials and determines what you're allowed to access. It uses protocols like LDAP and Kerberos to manage logins, group policies, and permissions. Without domain controllers, corporate networks would be a mess of unmanaged user accounts and inconsistent security rules. They are the central brain of its infrastructure in many companies. 3. DHCP server. If you've ever connected to Wi-Fi and received an IP address automatically, like a DHCP server. DHCP stands for Dynamic Host Configuration Protocol. And this server automatically assigns IP addresses and network configurations to devices on a network. Instead of manually setting up every laptop, phone, and printer, the DHCP server does it for you. It makes sure every device gets a unique address and knows where to send data. This kind of automation keeps networks fast, organized, and conflict-free. 4. FTP server. FTP stands for File Transfer Protocol, and FTP servers are used to upload and download files over a network. While FTP is an older protocol, it's still widely used today, especially in web development, data backups, and enterprise environments. An FTP server allows users to connect with client software, log in, and transfer files securely. Variants like SFTP, which uses SSA encryption, provide more security, which is essential when handling sensitive files. You might not use FTP every day, but it still powers large portions of backend internet activity. 5. Syslog server. Next up is the Syslog server, an unsung hero in its environments. This type of server collects and stores log messages from other devices on the network. Every router, switch, server, and firewall generates logs. Records of what it's doing, who accessed it, what errors occurred, and more. A syslog server centralizes all those messages in one place, making it easier for system admins to detect issues, troubleshoot problems, and audit activity. If something goes wrong on a network, a syslog server is often the first place tech teams look for answers. 6. NTP server. When millions of computers are working together, even a difference of a few seconds can cause problems. That's why networks use NTP servers, network time protocol servers, to keep all systems in sync. An NTP server provides accurate time data to other machines, helping coordinate transactions, logs, backups, and communications. Financial institutions, for example, rely on precise timekeeping to timestamp trades and transfers. Without time synchronization, data integrity would be a constant risk. That's the power of NTP servers. Invisible, but absolutely essential. 7. Caching server. A caching server stores copies of frequently accessed data to speed up future requests. For example, if hundreds of users are visiting the same image or web page, the caching server can deliver a saved version instead of fetching it from scratch each time. This reduces load on the main server and improves performance dramatically. You see caching in action every day. Even Google uses edge caching via their servers to speed up searches and web results. Caching servers make the web faster, especially when dealing with high-traffic content. 8. VoIP server. When you make a phone call over the internet, through WebEx, Zoom, or a business PBX system, you're using VoIP, or Voice over IP. A VoIP server manages the setup, routing, and teardown of those calls. It translates your voice into digital packets, sends them to the recipient, and ensures everything is synchronized in real time. VoIP servers also handle voicemail, call forwarding, and recording. As traditional landlines fade away, VoIP servers are becoming the backbone of modern communication. 9. Proxy authentication server. We talked about proxy servers earlier, but there's a specific type used just for controlling access: the proxy authentication server. This server ensures that only authorized users can access the internet or specific web services through the proxy. For example, a school network might use proxy authentication to block access to social media unless certain credentials are entered. It adds a layer of accountability and security, helping organizations enforce browsing policies and prevent unauthorized use. 10. Reverse proxy server. A reverse proxy server is similar to a traditional proxy, but it works in the opposite direction. Instead of sitting in front of clients and filtering requests, it sits in front of servers and manages incoming traffic. The reverse proxy can hide the identity of backend servers, distribute traffic, compress content, and even perform SSL encryption. Services like Cloudflare use reverse proxies to protect websites from attacks and improve performance through caching and load balancing. If you've ever visited a site behind Cloudflare, you've used a reverse proxy, even if you didn't know it. 11. Monitoring server. A monitoring server watches over the health of other servers and devices. It checks performance, uptime, disk space, memory usage, and network availability, sending alerts if anything looks off. Tools like Zabbix, Prometheus, or Nagios run on these servers, helping its teams spot problems before users notice. A well-set monitoring server can prevent outages, save time, and avoid disaster. It's like having a 24/7 digital doctor checking the vitals of your entire network. 12. Print management server. Print servers were covered in part 1, but print management servers take it a step further. These are used in environments with dozens or hundreds of printers, and they track everything from turner levels to page counts. They allow admins to control who can print what, monitor usage, apply quotas, and manage maintenance. This is essential for schools, offices, and institutions trying to reduce paper waste, cut costs, and ensure accountability. It's not just about connecting to a printer, it's about managing an entire print ecosystem efficiently. 13. Build server. Finally, let's talk about build servers. In software development, every time developers write code, it needs to be compiled, tested, and packaged into a working program. A build server automates that entire process. It takes raw code from the version control system, runs tests, builds the software, and reports results. This is the heart of continuous integration and continuous deployment. CI/CD pipelines. Without build servers, releasing new versions of software would be slow, manual, and error-prone. They're a key part of modern DevOps workflows. The more you understand, the more empowered you become. From load balancers managing internet traffic to NTP servers keeping time in sync, These machines do everything from securing your data to making sure your video calls don't drop. The more you learn about servers, the more you realize that the internet isn't magic. It's machinery. Thoughtfully designed, relentlessly maintained, and absolutely essential. If you found this video helpful, let us know with a like and subscribe for more breakdowns of how the digital world works. And tell us in the comments which server type was new to you or which one surprised you most. Thanks for watching, and until next time, stay curious, stay connected, and keep exploring what powers your world.